Now in this lecture we'll find out the value of x. In the drawing we have a quarter circle, AFE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, we know that this is line segment DE that is equals to 12 units in its length. This is angle GDC that is equals to theta, and this is angle EDC that is also equals to theta, and our mission is to find out the length of this line segment GD that's equal to x. We have to find out the value of x. So first of all, we know that all the angles inside a square are right angles, so therefore those four angles, they are all four right angles. So I write it down. Usually this angle equals to 90 degrees in its size. This angle is also a right angle. This angle equals to 90 degrees in its side. Finally, this angle is a right angle, it is equal to 90 degrees in its size. In addition, we know that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to side AB. So I write it down. In square ABCD, side DC is parallel to side AB according to the rule that the opposite sides of a square are parallel to each other. But AB is part of the straight line AE. Again, AB is part of the straight line AE and is parallel to DC. So if a part of a straight line is parallel to another straight line, then the straight line AE itself must be also parallel to DC. Therefore, AE is also parallel to DC. Write it down. AE is parallel to DC. AE is parallel to DC. Now we can implement here rule 15. Repeat again rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have line A is parallel to line B, and those two angles, alpha and beta, they are defined as alternating angles, and they are located between the parallel lines A and B, and therefore they are equal to each other. That is to say, alpha equals to beta. Here we can implement rule 15 in our drawing. In our drawing we have those two alternating angles, and they are located between the parallel lines AE and DC. AE is parallel to DC, and therefore they are equal to each other according to rule 15. So I write it down. This is angle EDC. And it is equals to this angle, this is actually angle AED. According to rule 15, because of the fact that those two angles are defined as alternating angles and are located between the parallel lines DC and AE, they are equal to each other. That is to say, angle ADC equals to angle AD according to rule 15. What is given us in the question that this is angle EDC is equal to theta. So we can write here that angle EDC equals to theta. And from this equation, theta equals to angle EDC equals to angle AD. We will derive that angle AED is also equals to theta. This is the angle AED. This equals to theta. In the next step, we will do a construction. That is to say, from point G, we will do perpendicular on AB. Again, from point G, we will do perpendicular on AB. So actually, this angle equals to 90 degrees in size, and this angle is also equals to 90 degrees, according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point of the perpendicular GN with side DC of D squared as M. By doing this construction, we created quadrilateral DMAN, and inside this quadrilateral DMAN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside quadrilateral DMAN to 360 degrees, this missing fourth angle must be equal to 90 degrees in its size. So actually, inside this quadrilateral DMAN, we have 4 right angles, and we know that any quadrilateral that has 4 right angles must be at least a left angle if not a square. So we relate to this quadrilateral DMAN with 4 right angles as a left angle. So write it down here. This is quadrilateral DMAN. It is actually a left angle because it has 4 right angles. GN is perpendicular on AB. Again, GN is perpendicular on AB. So GN is a perpendicular, it is absolutely a straight line. Again, GN is a perpendicular, it is absolutely a straight line. So if we focus on the left side of the straight line GN is point M, here the sum of the angles must be equal to 180 degrees. So which angles we have at the left side of GN at point M? You have this angle, that is a right angle, plus this missing angle. In total, the sum of those 2 angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles on the left side of GN, of the straight line GN at point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. And therefore, triangle GDM is a right triangle. Again, triangle GDM is a right triangle because this angle equals to 90 degrees. So I copy this right triangle GDM in your page, and we will analyze this right triangle, triangle GDM. The hypotenuse GD of the right triangle GDM equals to x according to what is given as the equation. That is the variable that we are looking for in this question. So actually, this is the right triangle GDM as I call it from the original drawing. In this right triangle GDM, it is very easy to see that cosine theta equals to GM over GD. Repeat again, in this right triangle GDM, cosine theta equals to dm, cosine theta equals to dm over gd. dm is the missing side, so we leave it as it is, so it is dm over gd. gd equals to x, so we substitute gd by x. So actually we found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally we get that according to equation 1, dm equals to x times cosine theta. Repeat again, according to equation 1, we shall find out that dm equals to x times cosine theta. In the next step, I'll copy this right triangle ADE in a new page, and we'll analyze this right triangle ADE, but before that, we define one side of this square ABCD as y, and therefore all the four sides of this square ABCD will be equal to y. That is to say, side AD equals to y, side AB also equals to y, side CB equals to y, and finally side DC also equals to y. So now we copy this right triangle ADE, but before that, what is the definition of line segment AE or side AE? Side AE starts from point A, that is the center of the quarter circle, and ends at point E, that is a point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle, and we define the radius of this quarter circle as R, therefore AE equals to R. So now I'll copy this right triangle ADE in the new page, and we will analyze this right triangle ADE. And the hypotenuse DE of this right triangle ADE equals to 12 units in its length according to what is given us the question. So actually, this is the right triangle, triangle ADE, as I call it from the original drawing. In this right triangle, triangle ADE, it is very easy to see from the drawing that cosine theta equals to AE over DE. Again, this right triangle ADE, cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. So in total, according to equation 2, we actually found out that cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. So we have here two equations. Here we can substitute cosine theta in this equation, equation 1, by r over 12 from equation 2. We'll do it now, and we get that according to equation 1, dm equals to x times cosine theta. And cosine theta according to equation 2 is r over 12. So in total, we actually found out that dm equals to xr over 12. dm, this is side dm, is equal to xr over 12. But we have already found out that quadrilateral DMAN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So a rectangle DMAN, side DM must be equal to the opposite side AN. Side DM must be equal to the opposite side AN. But DM is XR over 12, therefore AN must be also equal to XR over 12. Because those two sides are equal to each other. Likewise, according to the same rule, in the same rectangle, rectangle DMAN, side DA must be equal to the opposite side MN. Again, side DA must be equal to the opposite side MN in rectangle DMAN. But DA equals to Y, therefore MN must be also equal to Y. In the next step, join points A and G together by a straight line. And again, we join points A and G together by a straight line. What is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equal to R, according to our definition. Actually, by joining points A and G together, we created the right triangle, triangle AGN. So I copy this right triangle, triangle AGN in a new page, and we will implement on this right triangle, triangle AGN, the Pythagoras theorem. We just right now found out that the opposite AG of the right triangle AGN equals to R. It is also the radius of the quarter circle. We have already found out that side AN equals to XR over 12. So what is the length of this line segment? Line segment GN. From the drawing, it is very easy to see that GN in total equals to GM plus MN. Again, GN equals to GM plus MN. But before that, we will return to our right triangle GDM, and we will implement the Pythagoras theorem. We will continue to analyze this right triangle GDM. So usually, this is the right triangle GDM that I go with from the original drawing. In this right triangle GDM, sinus theta equals to GM over GD. GM is the missing side, so we leave it as it is, over GD. GD is x, therefore we substitute GD by x. So according to equation 1, sinus theta equals to GM over x. Here we multiply this equation 1 by x, and finally we get that according to equation 1, GM equals to x times sinus theta. In the next step, I'll copy again the right triangle ADE in the new page, and we'll continue to analyze this right triangle ADE. Actually, this is the right triangle ADE. That I copied from the original drawing. In this right triangle ADE, sinus theta equals to AD over DE. So sinus theta equals to AD, that is y, over dE, that is 12. So according to equation 2, we actually found out that sinus theta equals to y over 12. This is according to equation 2. Well, according to equation 1, we have already found out that Gm equals to x times sinus theta. So now we can substitute sinus theta in this equation 1 by y over 12 for this equation 2. We'll do it now. We'll get that Gm equals to x times sinus theta. And sinus theta is y over 12 according to equation 2. So in total, Gm equals to xy over 12. Gm equals to xy over 12. This is like Gm is equal to xy over 12. Now, we actually joined points A and G together by a straight line a couple of minutes ago, and we found out that AG equals to R. We already found out that AN equals to XR over 12. And finally, what is the length of this side Gn of the right triangle AGN? Gn in total equals to Gm plus Mn. That is to say, Gn in total will be equal to Gm, that is xy over 12, plus Mn, that is y. So in total, Gn equals to xy over 12 plus y. Here, this is the right triangle AGN. In the right triangle AGN, Gn equals to xy over 12 plus y. So here, by Pt is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle AGN is AG, therefore the square of the hypotenuse is AG square, and it must be equal to AN square plus GN square. AG is R, therefore AG square is R square, and this equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square, and XR over 12 square is X square times R square over 12 square, that is 144, plus GN square. GN is XY plus y, therefore xy over 12 plus y, therefore Gn square is xy over 12 plus y square. So according to equation 1, we actually found out that r square equals to x square times r square over 144 plus x over x times y over 12 plus y square. So according to equation 1, r square equals to x square times r square over 144. Here we take out y as a common factor from this expression. So y is taken out as a common factor. So what is left from xy over 12 after we took from it y as a common factor? What is left is actually x over 12 plus here what is left from y after we took omit y as a current factor, what is left is actually 1 all squared. So according to equation 1 we actually found out that r squared equals to x squared times r squared over 144 plus here we have this expression and we have the algebraic identity that a times b to the power of m equals to a to the power of m times b to the power of m. So according to this algebraic identity, we get that y times x over 12 plus 1 square will be equal to y square times x over 12 plus 1 square. Okay. Here we multiply 1 by 12 and then we divide it by 12 in order to have a common factor with x over 12, and we get that according to this equation, equation 1, r square equals to x square times r square over 144 plus y square, and here we multiply 1 by 12, so in total the numerator will have x plus 12 divided by 12 square. So here we use the algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m. And according to this algebraic identity, we get that x plus 12 over 12 square will be equal to x plus 12 square over 12 square. Okay. X plus 12 over 12 square equals to x plus 12 square over 12 square according to this algebraic identity that a over b to the power of m equals to a to the power of m times b over b to the power of m. So according to equation 1, we found out that r square equals to x square times r square over 144 plus y square times x plus 12 square over 12 square, and 12 square is 144. This is according to equation 1. In the next step, we will join points A and C together by a straight line. By joining points A and C, we can do the right triangle, triangle ABC. But what is the definition of line segment AC? Line segment AC starts from point A that is the center of this quarter circle, and then the point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equals to R according to our definition. Repeat again that by joining point C and C, created the right triangle ABC. So copy this right triangle ABC in a new page, and we implement on this right triangle ABC the Pythagoras theorem. Here by PT is the equation for Pythagoras theorem. Repeat again that the hypotenuse AC of the right triangle ABC equals to R. It is also the radius of the quarter circle. AB equals to Y, and BC also equals to Y. Both those two sides are the sides of square ABCD, and we know that all the sides of square ABCD are equal to Y according to all the sides of any square are equal to each other, and according to our definition, one side of square ABCD equals to Y, and therefore all the other sides must be also equal to Y. So finally, this is the right triangle ABC that are going to the region domain. According to the Pythagoras theorem, on this right triangle ABC, AC square equals to AB square plus BC square. In this right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equals to AB square. AB is Y, therefore AB square is Y square plus BC square. BC is also Y, therefore BC square is Y square. So according to equation 2, we actually found out that R square equals to Y square plus Y square is 2Y square. Repeat again that according to equation 2, we actually found out that R square equals to 2Y square. This is according to equation 2, while according to equation 1, we have already found out that R square equals to X square times R square over 144 plus Y square times X plus 12 square over 144. So this is the two questions that we have here. According to equation 2, this is equation to equation 2, R square equals to 2Y square. And therefore we can substitute R square in this equation 1 by 2Y square from equation 2. We'll do it now, and we'll get that according to equation 1, R square is 2Y square, and it is equals to X square times R square. Again, R square is 2Y square over 144 plus Y square times X plus 12 square over 144. Now we can divide this equation 1 by y squared. We do it now, we get that according to equation 1, 2y squared over y squared is 2, and here y squared will get cancelled, and we left only with 2x squared over 144, plus here y squared also will get cancelled after we divided the equation by y squared, and we left only with x plus 12 squared over 144. So here we multiply this equation 1 by 144, and we get that according to equation 1, 2 times 144 is 288, and it equals to, here we have 144 in the denominator. After we multiply the equation by 144, 144 in the denominator will get cancelled, and we left only with 2x squared, plus here we have also 144 in the denominator in this expression, so 144 will also get cancelled after we multiply the equation by 144, and we left only with x plus 12 squared. According to equation 1, 288 equals to 2x squared plus x plus 12 squared. So here when you open the brackets on this expression x plus 12 squared, you get that according to equation 1, 288 equals to 2x squared plus, here we have x plus 12 squared, x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12 is 24x. So according to this equation 1, we can find out that 288 equals to, here we have 2x squared plus x squared is 3x squared plus 24x plus 144. So here we subtract 288 from this equation 1. And we get that according to equation 1, here 288 minus 288 is 0. That equals to, in the other side of the equation we have 3x squared plus 24x, and here we have 144 minus 288 is minus 144. So according to equation 1, we can find out that 0 equals to 3x squared plus 24x minus 144. So here we divide this quadratic equation by 3, and you get that according to this equation 1, we have here 0 over 3 is 0, and here we have, it is equals to 3x squared over 3 is x squared, plus 24x over 3 is 8x, minus 144 over 3 is minus 48. So here we found out that according to equation 1, x squared plus 8x minus 48 equals to 0. And again, according to equation 1, we actually found out that x squared plus 8x minus 48 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, A, B, and C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. In our specific quadratic equation, x squared plus 8x minus 48 equals to 0. So here the coefficient a equals to 1. The coefficient b equals to 8. And finally the coefficient c equals to minus 48. So now we put the values of a, b, and c that we found for our specific quadratic equation, this x squared plus 8x plus 48. So we put those values of a, b, and c inside this general formula for x in order to find out the value of the values of x for our specific quadratic equation. Okay. We do it now, we get that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a. a is 1, so minus 4 times 1 is minus 4 times c. c is minus 48, so minus 4 times minus 48 is plus 192. Plus 192. So inside the root we have 64 plus 192 divided by 2a. a is 1, therefore 2a is 2 times 1, that is 2. So actually found out that x equals to minus 8 plus minus, inside the root we have 64 plus 192. 64 plus 192 is 256. So inside the root we left only with 256 divided by 2. So actually found out that x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x equals to minus 12. But x can never be equal to minus 12 because of the fact that x is the length of line 7GD. So x as a length must be a positive number. And therefore we cancel the solution that x equals to minus 12, that is a negative number, and we'll take into account only the positive solution for x. And the positive solution for x is as follows: x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8 over 2. 8 over 2 is 4. So if we found out that x equals to 4 units in its length. Repeat again that x is the length of line 7GD. That is to say, the length of line 7GD that is equals to x according to our definition, according to our given as the equation, is equals to 4 units. So here, okay, again the length of this line segment GD is equals to x is equals to 4 units. So that is the answer to the question. In the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment GD that is equal to x, according to what is given as a question. So in the drawing, we have a quarter circle. AFE is a quarter circle. Inside this quarter circle, we have this square ABCD. In addition, we know that this is line segment DE that is equal to 12 units in its length. This is angle GDC that is equal to theta, and this is angle EDC that is also equal to theta. Again, our mission is to find out the length of this line segment GD that is equal to x. Okay, so first of all, it is given us the question that ABCD is a square, and we know that all the angles inside any square are right angles. So those 4 angles must be right angles. In addition, we know that we have also the rule that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to side AB. Again, DC is parallel to side AB in square ABCD. But side AB is part of the straight line AE and it's parallel to DC. So if part of a straight line is parallel to another straight line, then the straight line AE itself must be also parallel to the other straight line that is DC. And therefore AE must be also parallel to DC. Again, AE must be also parallel to DC. Okay, and we have here rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have line A that is parallel to line B, and we have those two alternating angles, alpha and beta. And because of the fact that those two alternating angles, alpha and beta, they are located between the parallel lines A and B, they must be equal to each other. That is to say, alpha equals to beta. So actually we can implement rule 15 in our drawing. In our drawing, we have those two alternating angles. That is to say, this is angle EDC and this is angle DEA. So those two alternating angles, they are located between the parallel lines DC and AE, and therefore they must be equal to each other, according to rule 15. Again, angle EDC must be equal to angle AED, because of the fact that those two angles are defined as alternating angles, and they are located between the parallel lines DC and AE, and therefore they must be equal to each other. But it is given as the question that this is angle ADC is equal to theta. So I can write here that ADC equals to theta, and from this equation theta equals to ADC equals to AED, we will derive that angle AED must be also equal to theta. This angle must be also equal to theta because of the fact that those two angles are equal to each other according to rule 15. So angle AED equals to theta. This is angle theta. In the next step, we did a construction, that is to say, from point G, we draw perpendicular on AB. Again, from point G, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB is M. Likewise, we define the intersection point of the perpendicular GN with sides DC as M. By doing this construction, we get the quadrilateral DM and A. Inside this quadrilateral DM and A, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the must be equal to 360 degrees. According to the rule, the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Okay? So, this angle equals to 90 degrees. Therefore, inside this quadrilateral DMAN, we have 4 right angles. And we know that any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So, we relate to this quadrilateral DMAN with 4 right angles as a rectangle. Okay? Yeah. Quadrilateral DMAN is a rectangle. In the next step, we focus on the left side of the straight line GN at point M. On the left side of GN at point M, the sum of the angles must be equal to 180 degrees according to rule 3 that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the left side of GN? GN it is absolutely a straight line because of the fact that GN is a perpendicular. GN is a perpendicular, it must be a straight line. So which angles we have at the left side of the straight line GN is point M? We have this angle, that is a right angle, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, triangle GMD is a right angle, because this angle equals to 90 degrees. So I copy this right angle GMD in a new page, and we analyze this right angle, triangle GMD. So actually, this is the right angle, triangle GMD that I copied from the original drawing. It is very easy to see from the drawing that in this right triangle GMD, cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. dm is the missing side, so we leave it as it is. dg equals to x. Therefore, in total, we can find out that cosine theta equals to dm over x. Cosine theta equals to dm over x. We multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. Okay, dm equals to x times cosine theta. In the next step, I copied the right triangle, this right triangle, triangle ADE, in the new page. We analyze this right triangle, triangle ADE. But before that, we defined one side of square ABCD as y, therefore all the 4 sides of this square ABCD must be equal to y. The hypotenuse DE equals to 12 units in itself, according to what is given as a question, and side AE of the right triangle ADE is the radius of this quarter circle. We define the radius of this quarter circle as r, therefore AE equals to r. Why AE is the radius of the quarter circle? Because of the fact that it starts from point A, that is the center of the quarter circle, and ends at point E, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AE equals to r, it is the radius of the quarter circle. So this is the right triangle ADE, that I call it from the original drawing. In this right triangle ADE, it is very easy to see that sinus theta equals to dA over dE. Again, here cosine theta equals to AE over dE. Okay? Again, cosine theta equals to AE over dE. AE equals to R and D equals to 12. So in total, cosine theta equals to R over 12. This is according to equation 2, and according to equation 1, we already found out that dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1. by r over 12 for this equation 2. We did it and finally found out that dm equals to x times cosine theta, and cosine theta is r over 12, so in total dm equals to xr over 12. Okay, so dm equals to xr over 12. So I can write here that this is sine dm that is equal to xr over 12. And we have already found out that quadrilateral dm na is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle dm an, side dm must be equal to the opposite side an. Again, side dm must be equal to the opposite side an, but dm is xr over 12, therefore an must be also equal to xr over 12. Okay, in the next step I copied again this right triangle GMD in a new page, and we continue to analyze this right triangle GDM. So actually this is the right triangle GDM that I wrote from the original drawing. It is very easy to see that in this right triangle GDM, sinus theta equals to GM over GD. Again, sinus theta equals to GM over GD. GM is the missing side, so we leave it as it is. GD is x, therefore we substitute GD by x. So in total we can find out that sinus theta according to this equation 1 equals to GM over x. If we multiply this equation 1 by x, and finally found out that GM, according to equation 1, GM equals to x times sinus theta. Then I copied the right triangle AD again in this new page, and we continue to analyze this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. In this right triangle ADE, it is very easy to see that sinus theta equals to dA over dE. Again, sinus theta equals to dA over dE. dA is y, dE is 12, so in total we can find out that sinus theta equals to y over 12. This is according to equation 2. While according to equation 1, we have already found out that GM equals to x times sinus theta. So now we can substitute sinus theta in this equation 1 by y over 12 for this equation 2. We did it, and finally found out that GM equals to x times sinus theta, and sinus theta is y over 12, and therefore in total GM equals to xy over 12. GM equals to xy over 12. Here we can write down that GM equals to xy over 12. In this quadrilateral DMNA, that is a rectangle, we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side DA equals to the opposite side MN. But DA equals to y, therefore MN must be also equal to y. So in the next step, we join points A and G together by a straight line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore AG is the radius of this quarter circle that is equal to r. By joining points A and G together by a straight line, we create the right triangle AGN. So copy this right triangle AGN in the new page, and we implemented this right triangle AGN, the quadrilateral theorem. We just right now found out that the opposite AG equals to R. We have already found out that AN equals to XR over 12. And finally, GN equals to GM plus MN. That is to say, GN in total equals to GM, that is XY over 12, plus Mn, that is y. So in total, Gn equals to xy over 12 plus y. Okay, again, this is the right triangle AGN that I copied from the original drawing. We just try to now found out that Gn equals to xy over 12 plus y. Ga is the hypotenuse of this triangle AGN that is equals to r, and An equals to xr over 12. So in this right triangle AGN, according to the quadrilateral theorem, actually found out that GA square equals to n squared plus an squared again, or ag squared equals to an squared plus gn squared. Here ag is r, therefore ag squared is r squared, and it is equals to na squared. Na is xr over 12, therefore na squared is xr over 12 squared. Xr over 12 squared equals to x squared times r squared over 12 squared. That's actually 124. So in total, x over 12 squared equals to x squared times r squared over 124 plus gn squared. Gn is xy over 12 plus y, therefore gn squared is xy over 12 plus y squared. So here we took y as a common factor from this expression. If I found out that according to this equation, equation 1, r squared equals to 2x squared times r squared over 124. So here we took y as a common factor from this expression. So what is left from xy over 12, after we took from it y as a common factor, what is left is actually x over 12. And here we have y. So what is left from y after we took from it y as a common factor, what is left is actually 1. And all squared. In the next step, we multiplied 1 by 12 and then we divided by 12 in order to have a common factor with x over 12. So in the numerator, in the numerator of this expression, we will have x plus 12 because we multiplied 1 by 12. So it is x plus 12. And actually, but before that, we have here y times x over 12 plus 1 all under the square. So we use this algebraic identity that a times b to the power of m equals to a to the power of m times b to the power of m. So according to this algebraic identity, y times x over 12 plus 1 square will be equal to y square times x over 12 plus 1 square. And it is plus x squared times r squared over 144 is equals to r squared. So here we multiplied 1 by 12 and then we divided by 12 in order to have a common factor with x over 12. And we actually found out that in the numerator in total we will have x plus 12 because we multiplied 1 by 12. So in the numerator in total we have x plus 12 divided by 12 squared. And copy those to x squared times r squared over 144 is equal to r squared. So here we have this expression. We know that according to this algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m. We get that this expression x plus 12 over 12 square will be equal to x plus 12 square over 12 square. Read again. This expression x plus 12 over 12 square will be equal to x plus 12 square over 12 square times y square plus x square times r square over 124 that is equals to r square. So r square equals to x square times r square over 124 plus y square times x plus 12 square, and 12 square is 124. So this is equation 1. In the next step, we join points A and C together by straight line. Here we join points A and C together by straight line. What is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore AC is the radius of this quarter circle. That is equal to R. So by joining points A and C, created the right triangle, triangle ABC. So according to this right triangle, triangle ABC, in the new equation, they implemented on this right triangle, triangle ABC, the Pythagoras theorem. This is the right triangle, triangle ABC, the point from the original drawing. We just now found out that the opposite AC equals to R. Side AB equals to side BC. Why? Because of the fact that those both two sides, they are both the sides of square ABCD, and according to our definition, one side of square ABCD is equal to y. So in this right triangle, triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equal to AB square. AB is y, therefore AB square is y square plus BC square. BC is also y, therefore BC square is y square. So in conclusion, according to equation 2, we actually found out that R square equals to y square plus y square, that is 2y square. So according to equation 2, R square equals to R square equals to 2y square. This is according to equation 2. So copy this equation 2 again. Here, R square equals to 2y square. This is according to equation 2, and according to equation 1, we have already found out that R square equals to x square times R square over 124 plus y square times x plus 12 square over 124. So we have two equations. In both those two equations, we have R square in equation 2 and R square in equation 1. So now we can substitute R square in this equation 1, by 2y square from this equation 2. We did it, and we actually found out that according to this equation 1, R square is 2y square, and it is equals to x square times R square. And R square according to equation 2 is 2y square divided by 124 plus y square times x plus 12 square over 124. So here we divided this equation 1 by y square. And finally found out that 2y square over y square is 2. Here y square will get cancelled, and we have to leave 2x square over 124. Plus we have y square in this equation, so y square in this equation also will get cancelled, and we have to leave with x plus 12 square over 124. Here we multiply this equation 1 by 124. And finally found out that according to this equation 1, 2 times 144 is 288. So here 144 will get cancelled, and then left only with 2x square. Here also 144 will get cancelled, and left only with x plus 12 square. Here we open the brackets of this expression, and actually found out that 288 equals to 2x square, and x plus 12 square equals to x square plus 12 square, that is 124. Plus 2 times x times 12, that is 24x. So according to this equation 1, we have found out that 288 equals to, here we have 2x square plus x square is 3x square, plus 24x plus 124. So here we subtracted 288 from this equation 1, and finally found out that 288 plus 288 is 0. That equals to 3x square plus 24x, and here we have 144 minus 288 is minus 144. Again, 144 minus 288 equals to minus 144. So according to equation 1, we found out that 0 equals to 3x squared plus 24x minus 144. Here we divided this quadratic equation 1 by 3, and finally found out that 0 over 3 is 0, 3x square over 3 is x squared, 24x over 3 is 8x, and minus 144 over 3 is minus 48. So in conclusion, I actually found out that x squared plus 8x minus 40x equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula. x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 40x equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So now we took the values of a, b, and c for our specific quadratic equation. We will put them in the general formula for x in order to find out the value of the values of x for our specific quadratic equation. We did it here and we found out that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times ac. So it is minus 4 times a. a is 1, so minus 4 times 1 is minus 4 times c. c is minus 48, so minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So x equals to minus 8 plus minus, and here we have inside the root 64 plus 192, that is 256. So inside the root we have only 256 divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16, that is minus 24 divided by 2. Minus 24 over 2 is minus 12. So according to the first solution for x, x equals to minus 12. But because of the fact that x is the length of line segment GD, x as a length must be a positive number. Therefore, the negative solution for x is irrelevant, incorrect, so we cancel the negative solution for x because x must be a positive number. And the positive solution for x is as follows: x equals to minus 8 plus 16. Minus 8 plus 16 is 8, and 8 over 2 is 4. So actually found out that the length of this line segment GD that's equal to x is equal to 4 units. Okay, that is the answer to the question. X equals to 4 units in its length. Okay, thank you very much.